Hi guys, welcome to lesson 7 in the series of exceptions. In this lesson we're going to look at the try with resources that is added in Java 7. We'll discuss things like what are resources and why is it important to close them. We'll look at an example how we used to close resources pre-Java 7. We'll also look at the java.nio closeable interface, and which should be a capital there, the closeable interface. And then we'll look at the introduction, or they introduced the try with resources in Java 7, which would then also include the java.lang.auto-closable interface, and we'll see examples of using that, and then how to use the try with resources on our own custom classes and so on. So Wikipedia. In computer science, a resource leak is a particular type of resource consumption by a computer program where the program does not release resources it has acquired. This condition is normally the result of a bug in a program. Typical resource leaks include memory leak and handle leaks, typical file handling leaks, and so on. So we need to make sure when we open a file, read from it, that we close it so that it's not locked and so on. Okay, so what I'm going to do here is I'm going to read a file called ls.txt, which I've got here in the resources directory, ls.txt. So I've opened that directory. Sure you've seen this before. It's a text file about Alice in Wonderland. Okay, so I'm going to use a buffered reader to read this file, but I'm going to forget to close it. Okay, I didn't close the resources. So here I've got my static method called test1, and the source, it's pointed to that file there. I don't need this, I was just testing. I'm just going to take that out. Okay, my destination, I'm going to then my destination path is alice_back.txt. I'm using a buffered reader and a buffered writer, so I'm going to use the buffered reader to read, and I've got a reference variable input stream and a buffered writer output stream, which I initialize to 0, to 0. Okay, so because I'm reading and writing, it will throw a Java IO exception. So I'm going to put it in try-catch, and if there's an exception, I'm going to just print the stack trace of that exception. So in the try, I initialize my input stream to a new buffered reader, so it will return a buffered reader, and this is a Java NIO method in the Java NIO package, with the source and then the destination, the buffered writer. I'm going to read a line at a time, so I'm going to initialize my string line to 0, and then what I'm saying here is each line is when I read the input stream, I read the input stream a line at a time, while it's not 0 what I'm reading, because if it's 0 it will be the end of the stream. So each line will be assigned to, that read line will be assigned to line, and then I will write it. I use the outer stream to write that information from that buffer, and then at each line after it's read, I'm going to append a new line to the output stream. It's a method in the output stream and the buffered writer, in other words. Okay, so let's see what happens, because I didn't close it here. Okay, so let's run this. If I run it, everything goes well. It gave me no output, so it seems to have run. If I go here, you see there's my ls. I'm just going to refresh this so it will see if there's any change. And you see there's my ls back appeared there. So if I open this, and if I just go back to ls here, I'm back in ls. If I scroll down, let's see, goes all the way in, there's end at the bottom. So let's see this one. And it didn't. You see what happened? It didn't. The application didn't close, so the application ended before, and the buffer was still full because I didn't close. I didn't even flush. If it was a big application, you would have a flush in here, say every 1,000 lines flush the buffer or whatever. But there is no, what's important here is I haven't closed my resources, so I got the inconsistent state. In other words, my backup is not the same as my original file. Now that we know that we've got to close a resource that we use, like if we're reading files, where would you close it? Okay, that's the first thing we should think to ourselves. Because if something goes wrong here and it throws an exception, would you put the close in here? Or would you put the close over here and over there? Because if I close here and something goes wrong and it throws an exception here, then it will skip the close and it will come here. So then my resource didn't close because there was an exception. Now if you recall, the finally executes irrespective of what happens, if exception is thrown or not, and the finally is always executed. So ideally you would put the close, the close code or whatever you're going to call it, to close the resources in the finally. So let's go about that. Finally. Okay, so I'll put a finally here, and let's go and close the first one. Okay, how would you close this? Go about closing this. Okay, ideally you'd want to close the last one first, then the previous one. Okay, because you're writing and you're reading, so you'd want to close, let's say, the last one, which is output stream, because you want to make sure that once you've done the read, obviously the write was done as well. So output stream dot close. Stream dot close. Okay. But now it's giving me an error here. Okay, so we're picking up a problem here, that this one also throws an exception. Well, why is that? Now if we go and look at the output stream, the buffered reader, let's go look at it quickly. Okay, first of all, the buffered reader implements a closeable, and the closeable interface, that's where the close method comes from. So if I go look at the closeable, and you'll see a closeable, so any class that implements closeable, in other words, is a resource or destination of data that can be closed. The close method is invoked to release resources that the object is holding, such as opening files. Okay, and this is since 1.5, and you'll see here's the close method. Okay, so all the classes that implement closeable will have to implement this close method. But now, what is the implementation of this buffered class? So if I go back and I go and look at the buffered class, let's say we're going to look at the read and the write. It doesn't really matter. They both implement so I'm going to open its the source code. I don't want to open that again. So let's just go open the source code. And we're going to look at the close method. And you'll see here's the actual implementation of the close method in the buffered reader that I'm looking at. So it is a lock. So when one instance or instantiation, one instance of the buffered reader is closing, the other one has to wait. Okay, so of that specific instance. So you go, yeah, synchronize as a lock, and then if it's equal to null, it just returns. If it's not, then it tries to close it. So it's calling the buffered reader's close method, and then in the finally it's making them null. Okay, but it throws an IO exception if it can't close. So it is throwing an IO exception. So we have to handle the IO exception. Okay, so let's go here. So I've got to actually handle the IO exception. So I'd have to put this in a try catch over here. So I'd have to put this in a try and a catch here. And then would have something like print a stack trace, or let's say system.out.println line get message. Okay, so now I've handled this one. Okay, so I'll put it in a catch here, and I just want to make sure about this. Okay, so there I've dealt with my output stream, and then I have to do the same for the input stream. So I'll do the same here. I would say try, I'd say input stream dot close, and I would I can just copy this line of code because it's going to be basically the same there, and I'll catch it. Okay, so now I am trying to close this, and then I'm trying to close that one. Okay, but there's another thing. What happens on a null value? You have to look for nulls over here. So I would have to say, yeah, if in my output stream is not equal to null, then I do this. Okay. And now I would do that. Then I would do the same here. I would say if my input stream is not equal to null, then I do that. Okay, then I can only close it. Otherwise, if it's null, there's no point in trying to close it, because there is nothing to close. Okay, so I put this, and you see I've got to do this whole try catch in the if block over here. So let's just test it out. I'm going to just comment this one out, and I'm going to say test2. Let's run it, and let's see what happens now if I do it like this. And before I do that, I just want to mention another thing here. If I go and look at the close method here, I'll just close this one. I'm just going to call up the close method quickly, the auto close. In the documentation quickly. Just want to show you what they say about the close here as well. There's the method. There's a close method that's implemented. It closes the stream, flushing it first. So it should solve my problem of previously in the previous test where not all the data was written from the buffer before it closed. Even though I don't have a flush here, because it flushes it, then it closes. I don't have to call individually the flush, unless the file was very big, and you would have like say every 100 lines or something I would call a flush, and so on, and still the finally one, when it's ended, I'll call a close. Okay, so let's see what happens now. Okay, there's nothing, no output there. But if I go and refresh, I'm just going to delete this one. Let's just delete it and run it again, just to make sure we're actually looking at the fresh copy. Okay, there I ran it. I'm going to refresh it. And there it is. There's Alice. And there is my backup. And let's see what happens. My backup is there, 3,598 lines, and Alice 3,000, and exactly the same, no more problem. So this is how basically the code a person has to write to make sure that your resources are closed. You put it in a finally block, because now even if an exception is thrown over here, even if exception is thrown, it will come to the finally block. First check that it isn't null, because if it's not null, there's nothing you can close. So I check if it's not null, then I'll close it. I try and close it. And now why I've got two here, because even if this one throws an exception here, I handle the exception here, and the code will carry on here. So even if this one doesn't close for some reason, this one would still try and close. Okay, so as we can see, we've now put the responsibility of closing our resources in the finally block. And why we're putting it there is because irrespective of what happens in your code, if it throws an exception or not, the finally is always executed. And I've got a little graphic or a little picture showing that. As you can see, you got a try, and after the try you can have a catch, one or the other or both. And then here's the finally. As I say, a finally block always executes whether or not exception occurs in the try block. Okay, that is why a person would put the close or the code that's going to close your resources in the finally block. Now let's just have a look at our code again. As you can see, I'm actually handling the exception here. I'm not throwing it. So just to complete this, what would happen if in the close and in the exception, if an exception is thrown, we don't handle it here, we would throw it back to the client. So let's just try that. I'm just going to make a copy of this quickly so that we keep this one here. Just going to make a copy of it. I'm going to put it here. And I'm going to rename this one test3. And then here we're going to say we rather going to throw the IO exception. If something happens, we're going to throw it instead of handling it here. So we're going to throw the exception, the IO exception. So we're going to say throws an IO exception, telling it that it will throw the exception instead of handling it. So we don't need the catch here anymore because we're going to try. But if there's an exception, it's going to be handled over there. So in actual fact, we don't even need a try here because it's going to catch it there. So I can take this out, that there. That try would have been this one here, this catch here. Okay. But now I've still got a finally here. So as it says here, the finally block can only appear as part of a try statement. So we still need a try statement there. Okay, so I have to go back and put my try here as originally. Okay. And then over here, I don't have a catch anymore. I'm not going to catch it anymore. I'm still going to have a finally here, but because I've got it throws an IO exception here, I'm not going to handle it here anymore. So I'm just going to check for a null. Then I'm going to close, because if it doesn't close, I'm going to let the client handle it. So this try here and this catch I don't need anymore. So that's what my code is going to look like over here. Just going to tidy it a bit. Okay, we can just delete that line. We can leave the line there. It doesn't really matter. Okay, just for completeness, I will make it like that. And then the same with this one. I don't need this try. And I don't need this catch anymore. And you guys recall this, we've handled this in previous lessons. It's just to complete and just to show you the different ways. So this is now test 3. I'm catching an exception here. An IO, I'm throwing the exception. I'm not handling it. I'm declaring to throw it again. That's the word. Okay, so it's basically the same as what I'm doing here, but I'm delegating the exception to the client. I'm closing, finally, irrespective of what happens, I'm still closing my exception. I'm still closing my resources. Sorry, I'm still closing my resources. And if something goes wrong, it will be the exception will be handled by the calling client, which would be here. So let's just do this, and I'm going to handle it here. So over here I'm going to say test 3. And as you can see, test 3 must now declare to throw it or handle it. Let's handle it in this case. We could also have thrown it there and propagate it all the way, but I'm going to put it in a try-catch here. And yeah, I'm going to just print the stack trace. That's good enough. Okay, so there's another way. Now what happens is if it comes here, and it tries and close this one, it will throw an exception and it will come down here and handle it here. But let's see something in this case. If it's thrown it, will this one still be called? Will this stream, because even over here I tried it, I handled it here, and I can go to this one. What will happen in this case? So just to show you this, let's just simulate this. I'm going to say, I'm going to throw an exception here. Throw new, let's say IO exception. Let's say when it was trying to close, it actually threw an exception here. Could not close. And now to see if this one still, because it's a finally block, what's going to happen here? Let's see. So let's see here and here. I'm going to say system.out.println, and I'm going to say I'm going to say did close the second resource. Okay, so let's see. And now what's going to happen when I tell it to close? It's going to call the close, the finally, and then I'm throwing an IO exception here. Could not close, and then is it coming to this one? Because that one is throwing exception. So let's do that and see. You see, because this one here threw an exception, that one there was never handled. Okay, so this one here could not and did close. This is supposed to be close the second resource. Okay, I'm just going to run it again. Okay, now is the same thing happening in my first code here? So we must guard against these things. So what would happen in this one here? It's going to print a message. I'm going to say throw an exception here. Exception, and let's put the same. Let's just copy that one. We could just do this. Let me just copy that so that we get the same messages, although we don't have to. And I'm just going to go over here and do it over and throwing exception, and I'm trying to close it here, and I'm going to handle it here like that. I'm going to just show. Okay, so what happens in this case? What will happen if I now run test 2 again instead of test 3? Let's just do test 3. Oops. And I want test 2. Okay, so test 2, I'm checking over here and I'm forcing it to throw an exception here, and then I'm handling the exception here, and because it's handled, it's going to come to this one and it's going to close this one, even though this one threw an exception for some reason. It didn't close. So actually we could have put this thing actually in front of that, but then it's going to complain that it's impossible to get there. Okay, but we're simulating that over there. I could have just commented that one out, but it doesn't matter, just to give you an idea. And if I run this code, could not close, so I couldn't close this resource. You see there, could not close. it throws an exception there, which is handled. There's the message, could not close. That's the message that gets thrown there. But yet, I do close the secondary source. So we must guard against this. So in this case, where I'm using this, where I'm not handling exception here, if an exception is thrown here, it get handled handed back to the client, and then I've got a problem because my first resource didn't close. Doesn't mean my second resource shouldn't be closed. So in this case, we got you see where finally we should actually handle the sources at the source. At the where we're using it, because otherwise we are propagating the one to the client, and then the other one never got handled. At this test 3, we got a problem here that if the first resource doesn't close, as we are delegating the IO exception to the client, this code doesn't execute here. What can we do to sort this out? Recall that the finally always executes irrespective. So can't we use the same thing here? We could put this in a try here. Not here, sorry. We could put this in a try here. This one, the first one, and then a finally here. And then now let's just look at this, because if I try and close, an exception is thrown here, it's going to delegate it to the client. But remember that finally executes if an exception occurs or not. It will always. So if this one closes, it's fine, because then I'm going to the finally still runs here, and I'm going to close the second resource. But if this one throws an exception, it's going to be handled by the client, but irrespective, the finally code is still going to run, and it's going to close the second one. So let's see if that is true. Let's just see. I am throwing exception here. Yes. So let's see. Yes, that closed the second resource, and now that the first one could not close, it still gets delegated to where it's been called from. Okay, but now let's see what exception will be thrown if this one throws an exception and this one throws an exception. So I'm going to throw it here as well, and just change the message. Instead of giving me this, I'm going to say throws a new exception, could not close second resource, or let's just say, okay, let's say resource. Make it nice and long so we can distinguish. So which one of these two is going to be thrown? Well, it's going to throw this exception. The finally still get executed, but the finally also tries and closes, and it throws an exception. What's going to happen? Let's have a look here. Can you see what happens here? If an exception is thrown in a try-catch or try-finally or try-catch-finally, the exception that is thrown is always the finally exception. That is for the try-catch-finally. Okay, so this, if you can look at it, it's quite a bit of code to just close resources. as you can see, we are in test 2, where we're handling it here, or we're delegating it somewhere else. We've still got a lot of code, and we have to keep track of our resources, what we're doing it. Is it null, and is it throw? Now I want to show you a bug that I've got in this code, and it's a good example of a but. Note that this has got nothing to do with closing. The closing is fine, but there is a bug introduced here, and I'm sure some of you guys must have picked it up. If you look at my original file, my Alice, you'll see that it ends on 5398, but my backup ends, it adds an additional new line, an empty line at the end of the file. That is because I've got a bug in my programming logic. What I'm saying is read each line. If there is a line, write it, and then write the new line. So when it comes to the last line, it will read the last line, the end, and then it will add a new line, and that's what's happening over here. Okay, now to fix this programming logic, just to make our app complete, and I'm also going to add I mentioned flushing every so many lines, which the close does, but if it's a big file, it's always good to flush it, and I'm going to show you flushing every X amount of lines. So I'm going to add the following. At the beginning of my class, I'm going to add a static int called flush n times. This is just for stats purposes. I want to see how many times I actually called flush programmatically. That is calling flush excluding the close method that also calls a flush at the end. Okay, then to actually fix my code, let's start with test 2. I'm going to delete this here, this while, that's wrong, and I'm going to add the following code. Okay, and I'm going to explain to you guys what I'm doing here. I think I must just minimize this a bit so you guys can see it better. Okay, maybe if I make this one bigger, then I can make it bigger again. Okay, so what I'm doing here is I'm adding a counter to count the number of lines I'm reading through the text file. So each line I'll use that counter. Okay, then what I'm doing is when I come to the beginning of my file, I'll check if there's a line. If there isn't a line, I will exit. But if there is a line in my text, I'm talking about the first line now, it will write it to the buffer. Okay, it will read it to the buffer. Okay, so what happens is, yeah, if there is it's not null, I will read it and I'll write it to the buffer. Then I'll increment the counter by 1. If there's not, I'll return, and that's the end of my program because there's nothing. Now, now I'll look at the second line, and if there's a second line, I'll first write a new line, because in the first instance I didn't write a new line. So I'll first write the new line. So these two I've swapped around. Then I'll add 2 to my counter because I'm reading the text, and then I'm adding a new line. Okay, so this counter actually is now going to the next one, and then I'm using this here to flush. I want to flush it by every 1,000 lines, but because the counter is counting 2 there, I'm multiplying by 2 here. So it's every 1,000 times 2, so it's every 1,000 lines. I will flush it, I'll reset my counter, and I will increment that I called the flush, and I want to see how many times I call the flush as well. So let's save this and let's see what it does now. So I'm going to run it. I'm getting an error at the moment. I'm getting an error, and if I see it's on line 69, I've got a plus there for some reason. Okay, let's save it, let's run it. Okay, so that is working fine. Now let's see what happened. I'm just going to delete this so that you guys can see again. I'm going to delete that file. Let's run it again, just one more time. Okay, so if I refresh there now, there's my Alice back, and if I go look, it starts at line 1 and it ends at 5398, the same as Alice. 5398. So that's working. And why didn't it print my stats? Okay, I didn't give any stats, so let's just add the line of the stats itself. I'm going to add another line here of code here at the end of my main method that will print out the how many times I called the flush, and it called it 3 times, and that seems to be working fine, because I'm reading every 2,000 lines. And if you look at this, every 1,000 lines, and there's 3,000 lines, so 3,500 divided into 1,000 goes 3 point something, so it's called the flush 3 times. So yeah, that's how I fixed the one. Now we'll have the same issue with test 3 that we had with test 2. So let's fix that one as well while we're at it. I'm just going to do that and show you guys. So I'm going to run test 3 now and see what happens. Okay, so what we're interested is in the alice.back here, and you see that one line is back there. So we know where the issue is now, so we just need to copy and paste that code here, and it should be fine if I'm not mistaken. So let's take this code here, and it will be from my counter. Yeah, let's first go here, test 3. What I want to get rid of is I want to get rid of this while here, and I want to introduce the code that I modified here, including the flush and all that. So I'm going to take this from there until here, copy that, and I'm going to put it here after my line there, and let's save it. I don't see any errors there, so let's just run it. And the flush was called 3 times. That's great. And if I look at alice.back now, it sorted that one out as well. Okay, so that was just to fix a bug that we had, and yeah, an exception and so on. Okay, so I'm going to stop it here. In the next video of the series on exceptions, we'll carry on from here and look if there is an alternative way of dealing with closing the resources, as you can see, it can become quite complicated, especially if you've got a lot of resources to close. And please don't forget to subscribe, send me comments and so on. If you guys, any comments are welcome. I've also got a face page, as it appears there. And enjoy the rest of your day.